What's up, guys? Welcome back to another math tutorial video here. Today we're going to be doing the chapter 7 extra credit sheet for the chapter 7 test coming up on Thursday in Miss Meinhardt's class, so let's get right into it. Number 1 and 2 are asking if these are exponential growth or decay. I already did those because I had technical difficulties in the last video. So number 1, exponential growth, because of, you can tell by this because it's greater than 0 or greater than 1, whatever. And then right here we got decay because it's half, so it's obviously gonna be going down if you're smart enough to know that. So now we've got 7.12 that says I can graph exponential growth and decay functions and find the domain and range. Keywords here, domain and range, so we're going to be doing some little extra work, and we got to graph it, so we're going to have to get some graph paper. Or I might just draw it on here. I don't know yet, but let's get right into it. So right here we've got y equals 3x. So we've got our handy dandy TI Inspire, y equals 3x, and on the Inspire we're going to open this bad boy up. We're going to clear all this, and we're going to input y equals 3 raised to x, and we put that down, focus right there, and you control T to bring up the table. Oh, I all know this. I'm going to make a little table here, starting with -2, -1, 0, 1, and 2. We got 0.1, so obviously our estimate's going to be 0. So let's get some graph paper. I'll be right back. Alright, this says 3.3 homework and has a graph on it, but I don't really care. We're just going to cross those out. Input chapter 7 extra credit, and we got a little graph here. Okay, our table was -2.1, -1.3, 0, 1, 1, 3, and 2, 9. Obviously, we've got a exponential growth here with an asymptote of 0. So domain and range. Domain's going to be all real numbers, and range is all real numbers greater than 0. Okay, on to the next one. Number 4 is saying y equals 1/4 raised to x. So y equals 1/4 raised x. So we get our calculator here and graph that of 1/4 raised to x, and got ourselves exponential decay. So we're going to get our graph out here. And we gotta graph this, and we're gonna do the same. -2, -1, 0, 1, 2. So -2 is 16. So -2, we'll just go up to about here. -1 is 4. 0 is 1. And we got 0.25 and 0.0625. So our asymptote is 0 again. Y equals 0. Domain and range are all real numbers, and all real numbers greater than 0. And we're on to question 5, which is another graphing function. Thank you, Miss Meinhardt, for all the fun graphs. Alright, our question for this one is y equals 5 times 2/3 x plus 1. Well, this is a good one. Minus 2. Yay, so fun. Got our TI here, and we're going to go to town. So we're going to clear this. It's going to be a pretty lengthy video. Take me a day or two to upload. So we got 5. Oh, didn't mean to do that. 5 2/3 raised to x plus 1 minus 2. And wow, look at that. That is a great graph. And our asymptote is non-apparent. Our asymptote is going to be -2. Of course, we're going to do the -2, -1, 0, 1, 2. And we're going to get ourselves to 5.5. Put it right there. And we've got -1, 3, 0, 1.3. 1 is 0.2, so really close to 0 there. And then sorry, we're having some technical difficulties with the table here. And 2 is -0.5. So about right there. And there we go, we got some exponential decay. Y equals -2. All real numbers, and all real numbers greater than -2 is our domain. And range number 5. Alright, number 6. Great, more graphing. My favorite. You're gonna need a lot of graph paper for this. 6. Right there. That's the page. Number 6 is y equals 2x plus 1 plus 2. Okay, so get ourselves our TI Nspire here. Get rid of this. And we've got 2 raised to x plus 1. That's a negative sign. Plus 2. And exponential growth. Of course, we're going to do the -2, -1, 0, 1, 2 per usual. And focus there. -2, -1, 0, 1, 2. We've got 2.5, 3, 4, 6, and 10. I got no idea what the asymptote is. The asymptote's going to be 2, I think. Yep. So let's head right on over to the graph here. Okay. Draw ourselves a graph. We got -2, 2.5. We got -1, 3. We got 0, 4. We got 1, 5. And we got 2, 10. So we draw up there. Asymptote of 2, y equals 2, domain and range are all real numbers, and all real numbers greater than 2. Bam, let's throw it right into 7. And I already did 7. No, I'm just kidding. I don't have that editing magic. Number 7. Hey, we're finally done with the graphs. My favorite, though. So, number 7, we're moving on to solving application problems involving compound interest. So we're going to underline that. So our question is, the value of a new tractor purchased for $24,000 increases by 18% per year. Write an exponential decay model for the value of the tractor. Use the model to estimate the value after 15 years. Okay, so we're not going to need a graph for this one, thank the Lords. And we're going to put our TI off to the side and open up our notes, because we gotta pull up the equation here. This is our exponential decay model. Y equals A, parentheses, 1 minus R raised to T. So A is the initial amount, rate is R, and the growth factor and the decay factor. It's just great. So, number 7, Y equals, oh, let me get the question out here. Oh, let me plug in my camera. There we go. Business is booming. So, Y equals our initial amount is 24,000 and decreases by 18%, so 1 minus R, so R is the interest rate, so 0.18 raised to T, which is the time, and for ours this is 15 years. Grab our TI Nspire, we go to the calculate part, and we're gonna just plug this all in. So 24,000 parentheses 1 minus 0.18 raised to 15, and we get $1,222.98 is what our tractor will be worth after 15 years. Now that's pretty bad if you ask me, so don't buy a tractor if you're looking to buy a tractor. We're looking at about a 12-minute video here so far. It's gonna be about a 30, 45, 50, 60, 70-minute video. So next, we've got these bad boys. I can simplify and evaluate natural base expressions. So we've got E, lots of E's. Holy cow, I am intimidated, and I know that's what you're thinking. But this is not gonna be hard. Oh yeah, we forgot to rate these, so we'll just get these smiley faces. These are pretty easy. So 8, we've got E raised to -2 times E raised to 2 divided by E to the -4th. So we've got, well, E times E, it's just like a 1 there. And if you multiply exponents, it's like adding. So -2 or something. Something about exponents not being allowed down here, I think that's what it is. So I'm gonna go to the notes. Yeah, let's do that. Find that. Alright, so okay. Well, -2 times 1 is -2 times 2 is -4, so we got E -4 over E -4. I think that's how it is. And then you gotta switch them because negative exponents can't be in fractions. So you got E to the 4th over E to the 4th, so it equals E. Yay. I have no idea if that's right, so don't blame me if I'm wrong. Okay. Oh yeah, and if you're interested, make sure you like and subscribe. We'll put a message up right here on my hand. Like and subscribe if you're interested. Let's keep going at the 15-minute mark almost. Number 9. We got 24 e to the 8th divided by 4 e to the 5th. Well, everybody knows 24 divided by 4 is 6. If you don't, you might need to go in at lunch to Miss Meinhardt. Open most days during the week at school. Open every morning, unless she's got a problem with something else. But, you know, if you need help, go into Miss Meinhardt. I'll put the link in the description below to bhslovesmath.weebly.com. It's where you can check all your answers to your homework and get any notes or optional practices like this extra credit for our upcoming tests. Let's go back to the video. So 6, and right here, 8 minus 5 is 3. Everybody knows that. So 3 E's left. Nothing on the bottom because the 4 canceled out. The E's are gone, so it's just over 1. So the final answer is 6E to the 3rd. Booyah! Number 10 coming at you. This one says use a calculator to evaluate E times 3 to the 4th. Get our handy dandy exponents. Solver TI Inspire CX. So we gotta do E is right here next to the 10x right above the parentheses. So we click E and we put it in, but we have to do control divide for that 3/4. We enter, we're going to control enter, and we get 2.17. Or 2.12, and that is your final answer. So let's move on to number 11. Right there at the bottom. Alright, number 11. We got ourselves a new section. Gotta rate that with a smiley face. I can grab... Oh, yay. Thank you, Ms. Miner, for the graphs. I can grab natural-based functions and find the domain and range. Okay, so we got y equals 1/2 e raised to x. Only one question to graph here. So we gotta go back to the graph part. And focus that for you guys. Turn down our elevator music. And we've got 1/2 e raised to x. Enter. This is not the graph part. There we go. We got ourselves our table here. Very nice, very nice, very nice. Grab ourselves our graphing thing. Number 11. Do a tiny graph because we gotta start conserving space. Gotta save the trees. And looks like our table will start at -2 like usual because I'm a big fan of that -2, -1.2 stuff. One of my favorites. So -2. You guys can see that is 0.67. So very close to 0. Put that right about there. Then we got -1 is 0.18. Then we got 0.5, 1.35, and 3.69. Right about there. Just draw that. Alright, now we have to say our domain and range. And our asymptote real quick. And our asymptote's going to be 0, so y equals 0. Domain and range is all real numbers. And all real numbers greater than 0. Once again. Alright, let me check the thing for our next question. Our next question is a compound interest continuous question. It's down here at the bottom. You gotta write that with a smiley face. Yay. You deposit $8,500 in an account that pays 2.5 interest annually, compounded continuously. Find the balance at the end of 7 years. Okay, so we gotta hold on a sec so I can pull up our equation for that. Compound interest right here. So we get rid of our graph paper. Put our TI Inspire off to the side for a sec. And our equation is right here where I put the stars. A equals P 1 plus R over N raised to N times T. I know that sounds confusing, but it's not. P is the money you deposit. R is the rate, so in our case 2.5%, and N is the if it's semi-annually or annually, ours is annually, so it'll be 1. And then T is the number of years, so 7. So let's plug all that in for number 12. Number 12, so we got 8,500 times 1. After further review during editing process of the video, we lost one of our clips showing the end of question 12, and then 13, 14, and 15. So I'm going to just show you and briefly go over them right here. So we started question 12, so we're going to leave off right here. So you just plug all the numbers in, and then you plug this into your TI, this equation right here. And the answer I got was $40,531.20. So that was question 12, the finish to that. And then we move on to questions 13, 14. Question 13 was just figuring out, like putting a logarithm into an exponential equation. So you just basically put this down, this in the exponent, this is your answer. And then same with this, and this is your answer. And then 14, opposite of that, so you're just going to work backwards off of 13. So you got log base 12 of 12 equals 1 for that one, and then log base 4 of 1 equals 0 for this one. And that should be good. Thank you. Sorry about the technical difficulties. So let's go right into 16. There you go, 16 right there. We had some technical difficulties, so there's the answer. Basically what I can tell you is, right here, I can show you the equation on the notes. If it's composed with an exponential, it's got log base b raised to bx. It equals x, so the x would be 4. So the answer is just 4 there. So now we're in 17. We had some technical difficulties. So we're gonna just do that. So 17 is log base 5 of 25x. So our answer would be I believe it's gonna be 2x. Answer's 2x because of things that I'm not sure, but that's what the notes say. So the answer's 2x. Ask Miss Miner if you want clarification. It's not what I'm here for. I'm just here to do this. Alright, 18. We're finding the inverse of log base 4 of x. So log base 4 of x. Now inverse is tricky. So what we're gonna do is we're gonna take a look at our notes here. And in the notes, let's see what it's saying. For inverse, we're just gonna do this. You get rid of that, and then yeah, I got no idea what to tell to do here. So we're gonna skip 18 for now. Come back to that. So I'm gonna rate this an in-between smiley face. So we'll draw our own. It's a little half frown thing. So there we go. That's what we did. Because I'm good on these two, but sort of. We're just gonna go with this. Yeah, we just don't know what to do with that section. Okay, next section is 20 and 21. Miss Minor, you said this was 20 questions. More like 30. What the heck? Alright, so this is gonna be a lot longer than I thought, guys. Okay, for this section, it's I can use properties of logarithms. So, that's about it. So, oh wait, there's a little mini section, my bad. I can graph. Thank you for the graphs, Miss Meinhardt. Appreciate it. We got I can graph logarithmic functions and find the domain and range. So we have to graph and state the domain and range. So this is number 19 here. Okay. So for some reason, I'm gonna graph this. Let me get my handy dandy TI Inspire. And it's y equals 4 log x base 10 x, I guess. So I think that's what it is. Oh yes, of course. And then we control T, and we're gonna go, see, it's undefined because our domain is not restricted, not our range. So this is all real numbers. Our range is all real numbers, and our domain is all real numbers greater than 0. Let's graph this. We've got 1, 0, 2, 1.2, 3, 1.9, and then we'll just go down this to show I can't touch that, and then we get an asymptote of x equals 0, and that's about it. Okay, rate that with a smiley face, and we'll go on to the next section here of question 20, which is a lie, but whatever. Okay, question 20. I can use properties of logarithms. So we have to like break it up with these so we can do stuff with it like that. These ones are not too bad, simple enough for a student to understand. So let's get right into it. So what we have to do here is we've got log, actually I can keep this as a reference. We've got log 144, but log 12 equals 1.079 and log 5 equals 0.698. So we have to break up 144, so we know that 12 times 12 is 144. So that'll work. So what we want to do is it's going to be log 12 times log 12, I believe. Or wait, I believe that is incorrect. Let's see. We could do log 12 to the second power, I believe. So it would be 1.079 to the second power, which I believe, calculate that, is equals 1.16424. So your final answer is 1.16 for that, I guess. Alright, question 21. We've got log 1/25. So we could do log 5 to the negative second, I believe. Yeah, 5 to the negative second. So if we plug that in, it's 0.698 to the negative second, which is 2.05253. His final answer is 2.05. Okay, on to question 13, I guess, because Miss Meinhardt wanted to make it more than 20, even though she lied to me in class about it. So we're going to label this 22. And what we've got here is, oh, let me show you guys. We have to expand or condense a logarithmic expression. We'll give this a smiley face. Okay, so we have to condense this one. So 22 is 2 log 5 minus log x. And this is the exponent, so it goes back up. So it's log 5 squared minus log x. I believe that's the final answer, but I'm gonna double check in the notes real quick just to make sure. Condense. Oh no, we have to do what that is. So log 25 minus log x. And we cannot simplify that anymore. So that is your final answer. We're using a lot of paper here, Miss Meinhardt, so not my fault that we're running out of oxygen. Alright, so we got 24 here. And for that one, we're going to expand the equation. And it's ln 12x over 7. So to expand that one, seriously, to expand these ones, it's pretty simple. We kind of just break it back out, so it'll be take a little break here. Okay, so for this one, we're going to do ln 12x minus ln 7, and then it's ln 12 plus ln x minus ln 7. That's your final answer for expanding that. Okay, now number 25. We've got ln 5y squared. And for this one, it's going to be ln 5 plus ln y squared. And to do, since you've got this goes to the front, so it's ln 5 plus 2 ln y. And that is fully expanded to my knowledge. So that's going to be your final answer. And that one wasn't too bad, so we'll give that a smiley face. Alright, well, we had some technical difficulties. So this is how you do number 26. What you want to do is you want to get the bases to be the same, and then you distribute the inside exponent to the outside exponents, and you get the, equation. You just get x by itself, and x would equal 3 in this situation. So now we're on to number 27, which is a new section, so we'll give that a smiley face. We have to solve the equation by taking a logarithm of each side. So, and we have to check for extraneous solutions. So we've got 4x equals 11. So we've got log 4 of 4x equals log 4 of 11. And then once we do that, what we have to do, it's not too difficult, but it's a little tricky. Is you set, after you do that, you have to divide by, hang on. Well, the log 4 and the 4 will cancel, so x equals log base 4 of 11. So that's your answer there, I believe. So all you have to do now is put in your calculator what log base 7 18 equals, and it's x equals 1.485. So 1.48 is your final answer. Okay. Now we're on to 18. Solve the equation, check for extraneous solutions by using logarithmic equations. So what we do here is we've got log base 2 x minus 6 equals 5. Okay, so what we gotta do here is a little tricky, a little difficult, but nothing we can't accomplish. I lied, I was looking at the wrong question. I wondered why I wouldn't be able to do that. That's for the next section. It's 2 log base 5 of x minus log base 5 of 2 equals log base 5 of 2. Okay, so for that one, what we have to do is we first this and this. Okay, so if we take a look in the notes here, we have to get rid of the log. So it's, let's see, why is that? In the notes it's not like this. Geez, this is a little tricky. We just get rid of the logs because they're on both sides. So we just have what the heck? We'll be right back. Show us that. So what we're gonna do here for 29 is we have to exponentiate each side of an equation So we've got log base 2 x minus 6 equals 5. Alright, so for this one, what we have to do is, well, it says like log base answer equals exponent, so that'll help us out here. But if we look in the notes, what it's guiding us to do is just simply hey, let me read the notes. Okay, what we do is we're going to do 2 and put this above that. So 2 to the 5th equals x minus 6. 2 to the 5th is, let me get my power sheets. 2 to the 5th is, I should have known that, 32 equals x minus 6. We add 6. X equals 38. And that is your final answer right there. Okay. So, oh wait, we gotta plug it back in to make sure it works. So we got log 2 38 minus 6 equals 5. We'll plug that into the calculator to make sure it works. No, we can't plug that into the calculator. Yeah, it'd be 32, so it'd work. It works. It's not extraneous. Okay, so last question, ladies and gentlemen. Last question, and we're done. I know I skipped a few, but I don't know how to do them, so I'm going to come back to them myself. You guys can focus on that with Ms. Meinhardt. So what we're going to do here is we have to write an exponential function. So y equals a times bx, and these are our points. We got 172 and 236. And so what you do here is you just gotta plug x and y in. So 72 for y and 1 for x, and then take a look at the notes on the last page. And you gotta plug in the points and isolate a. So we have to divide by b. So a equals 72 over b. And then we're gonna do it again by plugging it in. So we plug in 80 equals 72 over b times b to, oh no, not 80, 36 to the second power. And then we have to isolate a again. And so a equals I'm not real sure. My notes are not very clear. Okay, so now what we have to do is not isolate a, because a is this. We have to set it equal to, so after further review, we do is put this over 1, and the b's cancel, so we get 36 equals 72 times b, since there's one extra b here. And then we have to divide by 72, and 36 divided by 72 is 1/2, my bad. 1/2 equals B. So then we plug that in, so A equals 72 divided by 1/2, and 72 divided by 1/2 equals 144. So A equals 144, and B equals 1/2. And those are your final answers. Oh no, then you have to plug it back in to get Y. So Y equals 144 times 1/2 X. Right there. That's your y-intercept, your final answer. Thank you, ladies and gentlemen, for watching this super long video. I really hope this helped for studying for Chapter 7 test coming up on Thursday. I know it helped me a lot. I know what I have to improve on. I hope you do too. This is one of my better videos, but I will leave a description down below. I'll leave the link in the description below to bhslovesmath.weebly.com, which is Miss Meinhardt's website, for all your Algebra 2 help. And also, she's not open tomorrow in the morning, but you can go in at lunch. And Thursday, I assume she'll be open in the morning. And I'm in the first hour, so going in the morning would actually really help. It'd be fresh in your brain. Thank you for tuning in for this video. I could have done a live stream, but I thought I'd edit it and make it look a little bit nicer, since I knew I'd struggle with some of the questions. So thank you for your patience. Thank you for your support on this channel. Make sure you like and subscribe if you haven't already. We're doing an iPhone X giveaway later this month. Stay tuned for that. But you gotta be subscribed and you gotta be liking all the videos. Go check out all my other math videos for any math help. I also got some cool other videos that I made. So you guys have a good one. Thanks for tuning in, and I will see you next time on the next video. Thank you.